All right, guys, we're going to finish activity 13 today when we start talking about isosceles triangles. So we're going to be developing and using some isosceles theorems. So we're going to get started on page 186. So open up your book so we can get going here. Okay, so we're going to start by defining what an isosceles triangle is. And we're going to be labeling this graph, this little picture below, with the vertex angle, base angles, leg, and base. So take a second. Do you remember what it means to be an isosceles triangle? Well, if you remember, and if not, that's okay, but an isosceles triangle is a triangle with at least two congruent sides. Okay, that's what it means to be isosceles. So when we're talking about the vertex angle, base angles, legs, and base, here is a picture of that. So the vertex angle is the top angle, okay? Your two legs are going to be the two congruent sides, and your base is the bottom. Now, the base angles are those angles that would be kind of in that low spot, okay, your two bottom angles. So that's what they mean when they're talking about base angles. So if it's an isosceles triangle, two of those, your legs, those are going to be congruent, okay? So we're going to jump down here to number 5, where it talks about the isosceles triangle theorem. And that isosceles triangle theorem is this: that if two sides of a triangle are congruent, then the angles opposite them are congruent also. So here in this triangle ABC, this is an isosceles triangle because you have two congruent sides. So what that means is if this side, BC, is congruent to the side AB, then their angles opposite them will also be congruent. So angle C is congruent to angle A. Okay, that's what that means. So the angles opposite will also be congruent. So your two congruent sides, the angles that correspond opposite of those will also be congruent. And we can assume that moving forward. So let's apply that with some questions up here. Number 7 says the measure of the vertex angle of an isosceles triangle is 80. What is the measure of the base angle? I'm going to take a triangle here. So let's label this. They said the vertex angle, member, is the peak angle. And they said that that is 80. So this is isosceles. We know that those two legs are congruent. They want to know what is the measure of these base angles. Can you get that angle for me really quick? What is the measure of both the base angles? Okay, well, those need to be congruent according to our isosceles triangle theorem. So if 80 degrees is used up, then we have 100 degrees left, right? Because 180 is the total triangle. Subtract off our vertex angle, we have 100 left. So that means each angle has to be 50 degrees because they're going to be congruent. They're the exact same measure. Okay, number 8, let's see what they're asking. The measure of one base angle is 25. What is the measure of the vertex angle? So again, if this base is 25, and we know that these are isosceles, we know that this angle is 25, making up 50 degrees. So what's left over for the vertex angle? Our vertex angle would have to be 130 degrees. Okay. All right, number 9, we're going to do a little algebra. So it said solve for x. So they're giving us an isosceles triangle because you can see these two sides are congruent. They're both 5. And our base angle is 2x plus 3. But then that also means that our other base angle is congruent. It's the same thing, 2x plus 3. Okay. So if we know that those are congruent, we have two base angles and our vertex angle. We can sum those up, right? So I could take 2x plus 3 plus my other base angle, 2x plus 3, plus my vertex angle. What do I have to set those equal to? It would be equal to 180 degrees, right? Because they're 3 angles of the triangle. All right, let's clean this up. 2x and 2x and 3x. That's going to give me 7x. 3 plus 3 is 6, minus 1 would give me a plus 5. So finish this problem here. What is x equal then? Well, hopefully you got that x is 25. If I subtract 5 on both sides and then divide by 7, I should get that x is equal to 25. Okay, in number 10, they want us to use the figure below. We know that PQ is congruent to PR. And we know that TQ is congruent to TR. We need to explain how we know that angle 1 and angle 2 then are congruent. So that's kind of what we're trying to prove here. Angle 1 and angle 2, trying to prove congruence with those two angles. So you can explain it using words. I might explain it using a proof because that's just kind of what we're used to. So I'm going to go through and explain how we could find that angle 1 is congruent to angle 2. So bear with me here for a couple minutes. So we know that PQ is congruent to PR because that was given to us. So if that's the case, then the angles opposite those legs should be congruent also, meaning angle PQR is going to be congruent to angle PRQ. And that's our isosceles triangle theorem. I'm going to abbreviate here. Okay, so let's do a little substitution here. Angle PQR would be angle 1 and angle 3. And angle PRQ would be angle 2 and angle 4. And that's just a little substitution here that I just did. So now if that's the case, our next thing we can look at is that littler triangle inside there where they told us that TQ was congruent to TR. That was given. Okay, so if that's the case in my little triangle, then those little base angles have to be congruent. So that means angle 3 has to be congruent to angle 4 because, again, the isosceles triangle theorem says if you have two equal sides, their angles opposite are also congruent. So then with a little kind of subtraction with kind of line 3 and line 5, that kind of helps me prove then that angle 1 is congruent to angle 2. Because again, if angle 3 and 4 are congruent to each other, if we subtract those out, we'll get angle 1 equal to angle 2. So I'm just going to put subtraction property of equality. So you could have explained it using words. I just think it's a little easier just to kind of organize my thoughts using a proof because we're just used to doing proofs. But that's how I would prove that those angles are congruent. So if you ever see a picture like this again, we can always know that angles 3 and 4 are congruent, angles 1 and 2 are congruent, okay, and that entire big base angle, those angles are also congruent. Okay. Let's just talk really quick about an equilateral triangle. So something we know about equilateral triangles is all the sides are congruent in an equilateral triangle. So if that's the case, an equilateral triangle is also what we call equiangular, because according to that isosceles triangle theorem, okay, let me draw like a real quick triangle. This looks pretty equilateral. So in an equilateral triangle, all sides are congruent. So according to this, then, your base angles would also have to be congruent. But if they're all the same side, they're all going to have equal angles as well. Okay, so just know that about an equilateral triangle. It's all the sides are congruent as well as all the angles. All right, let's move on. I'm going to have you guys try number 14, and then we're going to be done with this lesson. So in number 14, we have a triangle ABC. So I would suggest drawing a triangle on the side of your notes here, labeling it A, B, C. They tell you that angle A is congruent to angle C. And then they give you all the measurements for each side length. So AB is 4x plus 25. BC is 2x plus 45. And AC is 3x minus 15. So what they want you to do is determine the lengths of the three sides. So first you have to solve for x. So use what you know about the picture and how you can set up an equation. Find x, and then plug x in to find AB, BC, and AC. So take a minute and try this problem right now. Okay, here is my work. Let it fade in here. So if those sides have the same angles, if angle A is congruent to angle C, that means AB has to be congruent to BC. So I set those two side lengths equal to each other, did all my algebra, and got that X was 10. So if I plug 10 into each of my equations here, each of my expressions, I got that AB was 65, BC is congruent, it's the same measure, and then AC was 15. Okay. So the big takeaway of today's lesson is knowing that isosceles triangle theorem, which just says if we have isosceles triangles with two sides congruent, their angles opposite will also be congruent. So we can set up problems using that theorem.